This is Katie Bowman's AP problem number 10 or 11. Let's start by reading the question. Account for each of the following observations in terms of atomic theory and or quantum theory. Explain with as much possible as detail. No, as much detail as possible. So part A asks, atomic size decreases from Na to Cl in the periodic table. And so my answer for that happening was moving across a period, the number of protons in the nucleus, which creates so the number of protons within the nucleus increases, which creates a greater attraction between the outer valence electrons, and the nucleus pulls them in closer because the attraction is stronger. So it becomes smaller because it's being closed in more. So that's why Cl is smaller than Na. Let's see. Part B says the first ionization energy of K is less than that of Na. I said K has one more energy level than Na, putting the valence electrons further from the nucleus, decreasing ionization energy. So what happens with Na is it has 3 energy levels while K has 4. So there's another whole entire ring, so it moves the outer valence electrons away from the nucleus, so the nucleus has a less strengthened attraction with the outer shells. It doesn't pull it in as much, and it doesn't have as strong of an ionization energy because it has to be spread out so far. So part C says each element displays a unique gas phase emission spectrum. So I said they all have a different electron configuration, and when electrons absorb quanta of energy, they move into a more excited / spontaneous state. When it becomes less excited, energy is released as radiation, like electromagnetic radiation. The radiation has specific wavelengths for each photon emitted, which relates to the gas emission spectrum. So it absorbs quanta of energy while it's all excited, it's all absorbing it, and then it relaxes and it starts to release it as electromagnetic radiation. And each photon worth is a certain wave, and it all relates to the gas phase emission spectrum. So part D says the Ca2 plus and Cl minus ions are isoelectronic, but their radii are not the same. Which ion has the larger radius? Explain. So for part D, I said Cl is larger because as it gains electrons, the extra electrons repel each other, pushing them further from the nucleus. So electrons don't like to be next to each other because they have the same charge. So they start to repel each other and push each other farther away. Like when you have a magnet with 2 negative sides, it never wants to touch, it always just wants to get away from each other. So they repel each other, and they move all the electrons further away from the nucleus. So yeah. Or you could say the opposite, the protons. There's more protons in the nucleus for the Ca, so it starts to pull all of the electrons in. There's a stronger bond, there's more energy to pull them in, more connection. Compounds containing krypton have been synthesized, but there are no known compounds that contain helium. So I said helium has a higher ionization energy, so its electrons are pulled in closer to the nucleus, so they're harder to get away from it, really, really hard. And then while krypton has a low ionization energy, and its valence electrons are more likely to be taken, so it's more reactive. So it has more shells for one, and then it has a low ionization energy, so the protons aren't really pulling the electrons in, and they're really, really far out. They're just spread to the wind, and so it's really easy for another element to react with it. It's more reactive than helium because its electrons are so like split out and frayed and all that. Yeah, that's it. Thanks.